In this video, we're going to use the intersecting secant theorem to form and solve a quadratic equation. Let's remind ourselves what the intersecting secant theorem was. And secant is just a line that cuts through the circle. Secant comes from the French sequer, which means to cut. So it's just a line that cuts a circle, as opposed to a tangent, which would touch the circle. So if I had a line like this, which touches the circle, that's called a tangent. Now, the way it works is this. From this point outside the circle, I do the distance to the first point where the secant cuts the circle, and the distance from that point again to the second point it cuts the circle, and find that product. So it's A multiplied by B. And that product will be the same as if I do it for the other secant. So this C multiplied by this D. So that's how it worked. So let's apply it to this one. We're going to do the distance from this point here, T, to the first point it cuts the circle. So we're going to have 2x minus 3 multiplied by the distance from this point to the second point it cuts the circle. So that total length there is going to be the 2x minus 3 plus the 8, which is going to be 2x plus 5. So it's times by 2x plus 5. Let's just get rid of that blue line so the 8's visible. And now we're going to do the same to the other secant. So from this point to here, the first point it cuts the circle, so it's equal to x multiplied by the distance from that point to the second point it cuts the circle, which is here. So it's x plus 16, that length, so x plus 16. And now we need to expand those brackets and solve this quadratic equation. So now we need to just expand and solve this quadratic equation. Each thing in the first bracket times each thing in the second. So 2x times 2x is 4x squared. 2x times 5 is plus 10x. We've also got minus 6x, and we've also got minus 15. And that is equal to x times x, which is x squared, plus x times 16, which is 16x. Now, if we get everything on one side, let's say the left-hand side, because there's more x squareds there, we can see we've got an x squared term here and here. So if we subtract x squared from both sides, we get 3x squared. Let's put it down here so we've got more space. And then we've got this 10 lots of x minus 6 lots of x. And let's minus this 16x on the other side. So that is 4x. Minus that 16x, we get minus 12x. So we get minus 12x. And then finally, I can see we've got this constant term of minus 15. So let's put that here. Now, because all these terms are divisible by 3, we can simplify this quadratic by dividing everything by 3, like this. And that is much easier to factorize now. Now we need two numbers that add to give the coefficient of the x term, the middle number, and times to give this last number, the constant term. So we need to add to give the minus 4 times to give the minus 5. Those two numbers are minus 5 and plus 1. So therefore the factorization, two brackets, we have x as the first thing of each bracket because it's a quadratic in x. And the two numbers were minus 5 and plus 1. So we put those numbers as the second thing of each bracket, either way around. And then what we do is we say, well, if the product of two things is equal to 0, then at least one of these things is 0. So if the x minus 5 is 0, 5 minus 5 would be 0, so x is 5. And for the other one, if x plus 1 was 0, then x is equal to minus 1. Now, in the context of this problem, what could x actually be? Well, we can see that x is a length here on its own. Now, that length can't be negative. You can't have a length of minus 1. So therefore, x must be 5, the positive value. And so that is the answer. X is equal to 5. And we're done.